Boom! What's up, everyone? Welcome to Simulation. I'm your host, Alan Sakyan. Very excited to be talking about carbon products from the air. We have Tito Jankowski joining us on the show. Hello.
Hey, how's it going?
Thanks so much for coming on, brother.
Great to be here.
Very pumped, very pumped. For those that don't know Tito's background, he's co-founder and CEO of Impossible Labs, which is creating carbon products pulled from the air. And you can find the links below to the newsletter, as well as bynegative.com, that's bynegative.com, as well as impossiblelabs.io and airminers.org. And we'll be pulling those up as we talk. Tito, let's start things off with one of our favorite questions to ask our guests. What are your thoughts on the direction of our world?
The direction of our world, I found out this recently from a presentation on the planet. A lot of people think that the planet kind of goes around the sun, but actually in time, it's actually this like helix.
Yeah.
I heard at the Bucky Fuller presentation. So that's what's up with the world. Continual helix. Things we're sort of at the same place, but also not.
And then what would you say about some of the pressing challenges that we face as a civilization and how to overcome them?
Oh, they're great.
It makes the game
This is
interesting.
the coolest challenge we've ever had, right? I mean, this is where it's at. This is like definitely the time to be born. I mean, the sky is empty. We just see regular-looking stars. Our planet. We've figured out things like processors and proteins, but we're sort of in between those two things. We're here, and there's all this, ahead of us. So we're kind of writing this first paragraph of what we can tell is a really, really long book, which is exciting.
Yeah, I love it. And then you mentioned, processors and proteins. What are some of the most important exponential technologies to help us get through the next century, let's say?
Next century? Gosh, I think that climate is a big one. That's what I'm working in. I think trust is really important. The tools that we have for trust, they weren't designed for the type of trust that we need now. And everything that we're doing with carbon, whether it's monitoring carbon, learning how to use it more effectively, or pulling it out of the air, I think those are key technologies that we are just beginning to take a look at. It's really exciting.
Yep, I'm super pumped to unpack that more with you. Let's jump into the journey. So you're born in Florida, then you moved to Hawaii at 4, then you stayed there until you're 18, then went to Brown, and then moved to Silicon Valley.
That's right.
So tell us about this journey. Who were you as a kid, and what got you hooked into science and technology?
What got me hooked into science and technology was my parents are oil painters, and so growing up in Hawaii, they would kind of drag me out to go painting with them. They would go and sit in a cow field with cow hanging out or whatever. They're painting the landscape, and I would just think about just more mathematical things, or more how do these things all start to fit together? What makes a cow a cow? Why is the grass blowing? And just caught my interest. And kind of grew into an interest in science and technology. Biotechnology really was an exciting discovery, just of that everything is made of DNA, right? That grass, that cow, us is all, there's this code that's running all of us. And then that grew into an interest in the planet as an entire kind of biological cell. How does that work? What's the beauty in it? What can be improved in it?
Yeah.
And that brought me to you today.
Yes. Okay. So let's stay on that biotech a little bit longer. Mm-hmm. So then it was, when you're both in college and moving out here, and you're really figuring out biotech is something that's so profoundly important. What is it about biotech that is like a really awakening thing for you?
What's awakening for that is, and it's very similar to my interest in climate, is this feeling of looking at a Rosetta Stone and saying, there is language here, there is knowledge here. We don't have it yet, but that to be able to see there is a point where we will, and so sometime between now and then, there's going to be this beautiful ability to read, ability to understand, ability to write our own story, whether that's DNA with biology or carbon with the climate.
Yeah. Okay, so it's like we are gaining more authorship of
Yeah,
this
right.
civilization story.
Authorship, cool.
Yeah. Okay.
Like
okay.
it.
I like that a lot. Tito, move back just a
Yeah,
little
sure.
bit. Okay, perfect. Awesome. All right, and then let's hit on the mission of Impossible Labs. It's been 3 years now. The co-founder and CEO, and you're pulling CO2 out of the atmosphere. It's the greatest opportunity civilization I've ever seen. Climate, you say that's what it is, and people need to be handling these tangible things that we're going to be talking about here in a little bit. So why don't you tell us a bit about what you guys are doing with Impossible Labs?
Yeah, terrific. I mean, the overall, there are 1 trillion tons of excess carbon dioxide in the atmosphere. It's free. Nobody knows what to do with it. Nobody even really wants it. If we can figure out how to pull it out and to make use of it, we can change how the planet works, change our understanding of what we understand water, we understand kind of these macro molecules, but gases are still something that we struggle to deal with. And so it's kind of this final frontier of exploring what are the mechanics that make this planet.
And this is 1 trillion, you said, tons of excess CO2 that can be sequestered. And that's excess, so that's past where it was.
Yeah,
okay.
That's right.
Okay.
It's 415 parts per million as of today.
Yeah. Wow, and it was closer to like 300
Yep.
or so in the past. Okay. So you guys are exploring new business opportunities in climate change with this greatest opportunity that we have. And one of the things that you guys are doing is you're making these tangible physical products. Okay, so walk us through these.
Yeah, that's right. So this is made of carbon dioxide that was in the atmosphere that was pulled out. The little white dots are little beads of calcium carbonate, and the carbon dioxide that's in that was pulled out of a direct air capture machine up in Canada, run by Carbon Engineering, which is a company that's working to build these machines that can take molecules of carbon dioxide out of the atmosphere. So a lot of times we hear about putting carbon into the atmosphere, and we certainly put a lot of carbon into the atmosphere. But our ability to actually pull it out is an emerging discovery of how do we actually go the other way and start to pull carbon and use carbon.
Okay, and then this right here, this like container for this plant, these containers for the plants, you sold out within 1 hour of these because people like the idea of like a tangible physical asset that they can have in their home that says that, hey, I'm partaking in the process of awakening with sequestering carbon from the atmosphere.
That's right, and it's something that as a team we were always, when we started Impossible Labs, kind of searching for that. How do we plug into climate change? How do we grab onto it? How do we just poke at it? And this is I think what people are seeing is this is an opportunity to grab onto something that's just it's been on the news, it's been on TV, but it's never been something we can just kind of hold and say, what do you think about this? It's always been that somebody else is thinking about and working on it, and now we can. Now I can. Now you can.
It's been like a PowerPoint or like a news story.
Yeah, right.
You gave this example to me before the show. You were like, there's like civilization, like 8 billion of us are like at the door trying to get in, but no one's making a handle for the door. And so these products are kind of like a step towards the handle for the door to get through the climate challenge.
Yeah, exactly. Often working on the changing climate, it feels like, am I doing enough? Am I solving the whole thing at once? And I see a lot of people get stuck right there. And what we wanted to do was to unlock that and to say, look, here's a place where you can grab onto it and start to move the whole thing. I think we need more of those places that individual people can grab onto. There's certainly a role for collective action, but I think individuals, single people doing a thing really is where this is where things change.
Yeah. And then, so batch 2 of these is coming up, and batch 2 of these can be found at Buy Negative.
That's right. We have a weekly newsletter that you can sign up for, where we talk about our prototyping. We're working on an up-and-coming product that's a bracelet that you can wear.
Yes, okay, and that's this one here. Okay, so the up-and-coming product is these bracelets that we can wear. Okay, and then teach us about the idea behind the bracelets.
The bracelet was coming from the planter. We said, how do we help people, how do we give people a tool? Fundamentally, these are tools to have a conversation, to change how you think. So we want to have something that you can keep with you. So I'm really into this, so I carry the planter.
You carry the planter out. You walked in carrying a plant. Yeah, that's right. Yeah.
But most people don't want to do that. So we said, how do we take the same stuff and imbue it into something that you can use? And so this is a prototype, but we're working on using the materials that startup companies are making that pull carbon from the air. They have a lot of these raw materials that people are still trying to figure out how do we use that? Things like cement or plastic. I don't buy a lot of cement. I don't buy a lot of just raw plastic. So how do we make those things that, again, that individual people can grab onto and use to better explore and be curious about the climate?
And then what would you say on I want to explain this to people. We'll pull up airminersnow.org. Explain to us, this is an index of companies and projects mining carbon from the air. Finally, there's like an index of companies. That's very exciting. And I want to know, like, for this and for these products, explain to us how the companies are actually doing the sequestering of the carbon from the air. How are they pulling the
Certainly.
carbon? Yeah.
This is where we started our journey, was around curiosity. I think that if you're wondering how to change the climate and to be a part of that, I think curiosity is the key. So we started out just learning about all these companies that were talking in some way about carbon and pulling it and doing something with it. And we had a spreadsheet of all these companies, and we discovered, hey, this is something that probably hasn't really been put together in this way before. And so we created Air Miners, which is the index of companies and products pulling carbon from the air. So it was just this immense curiosity that drove us to find these companies, connect them all together, and start to ask, well, what can we do with this stuff? And that's where we really start to say, okay, how do we make things using the carbon that the air miners are pulling out of the air?
Yes, and then what is the method that the carbon miners are using? What, is there like a method that most of them are using that is most common?
Yeah, there's kind of two ways to look at it. There's biological pulling of carbon, and then there's synthetic or engineered. So biological is easy. If you think about trees, they're pulling carbon dioxide from the atmosphere, and they're using it to make their trunks and leaves so they can keep doing more of that. And then there's engineered, which is, can we build a filter or a sponge that grabs onto carbon dioxide, and then we can either put it in a tank, or we can bury it, or we get this like 99% pure carbon dioxide, and that's really exciting. So that's kind of the overall view of air miners. And what we wanted to do was, we didn't want to curate it so much, because we think for curiosity that what really matters is kind of stubbing your toe on stuff and bumping your head on stuff and just kind of seeing it. And so we put up every company that we could find that was doing any of this stuff. And you can sort them by alphabetical, you can sort them by when they were added, but generally we don't take a stance on like, is this company better or more successful or something. They're all the same, and they're all kind of ripe for people who are curious to come along and say, wow, what's up with this? How does this work? Biological, engineered, making products, making carbon. How does it work?
Nice. Okay, so then the two, biological and engineered, are the two big ones, and it seems as though there are plenty of organizations now around the world that are doing things like planting trees, or that they're trying to make it so that all the phytoplankton in the ocean can continue staying healthy and doing what they're doing. Apparently that's the source of like 70% of our oxygen creation on the planet.
Wow, that's right.
Yeah. And then on the other hand, there's the engineering. So there's, like you said, like making a sponge for the CO2 and then turning that into, so when you do compress CO2, it turns into like a rock, or how do they turn it into, like, how do they take CO2 through it? Is it like a filtration, and they're just like, no oxygen and nitrogen, we're only keeping the CO2? Like, how does that scientifically work?
Yeah,
you know?
basically, so there's kind of two steps in that. One is capturing carbon, so separating it out from all the other stuff that's in air. So carbon is only, I think it's 0.04% of normal air,
okay.
That's where you get that 400 parts per million. So there's capturing it and separating it, And then there's kind of what do you do with it afterwards? And so what's wonderful about looking at across the breadth of air miners is you see companies that are specializing in the different pieces. So some of them are just capturing carbon dioxide, and in terms of what do we do with it, they're kind of like, maybe somebody else will figure that out. And somebody else is working on how do we make use of carbon? How do we actually use the molecules and then transform them into building materials or plastics or products?
Okay, and do we know how it works when they do the separation of the 0.04% of CO2? Do we know like how to get the oxygen, nitrogen out of the way and just keep the CO2?
Yeah, a lot of the technologies right now are chemical separation.
Okay.
So you have a material that will kind of grab onto carbon dioxide, and then that's a way to separate carbon dioxide out from everything else that's in the air. So in the end, it comes down to very simple chemistry. So the calcium carbonate beads that are used in the planter, those are actually sponges that are part of the direct air capture machine. So they get reused over and over and over again, grab a carbon dioxide, then get heated up and release the carbon dioxide, grab a carbon dioxide, release it. So it's this cyclical technology in that particular example.
Okay, grabbing it chemically and then releasing it also chemically into what is only then CO2.
Right.
Okay, and then from there, then it's in a gas form.
That's
and
right.
then we're figuring out how to turn that into a solid. How do we know how we do turn it into a solid? Then again, another chemical change.
Yeah, another chemical change. I mean, if you think about kind of the basics, it's carbon dioxide and oxygen. Carbon dioxide is carbon and oxygen. Diamonds are made of carbon. We're made of carbon. So it's sort of like there are lots of examples lying about of things to do with carbon, but it's kind of murky in the middle of it. We can see it's in the air. We can see it gets used to as the building blocks of the planet, and we're kind of figuring out and kind of untangling what's in the middle.
Okay. And then the applications then are some of the companies that are part of air miners will do just one part of that process, or some will do a lot of the process, and then some will also do like the actual burying of. So the burying is one aspect of it. So we can bury the rock then of CO2 back into the ground. You said it was an Icelandic company?
That's right. There's a company called Climeworks that is setting up a facility to be able to take carbon dioxide from the air, separate it out, and then inject it underground where it just merges and fuses with the rocks underground. So it's back to that trillion tons of carbon again. We can make products out of some of it, but the trillion tons is a lot of excess carbon in the air, and we added the most ever in 2018. So we're just adding more and more and more carbon. So some of it we need to use, and a lot of it we probably need to store.
Okay. So we can then use some as like for fuel. Is that right? We can use some for fuel, and we can store some in the ground. We can wear some. That's kind of the ideas. Okay.
Yeah, building materials. You can imagine graphene, cars. Just imagine kind of walking into a park, and your frisbee is made of this material, and your sidewalk is made of carbon that's been pulled from the air.
Interesting.
You can start to visualize what this new world would look like, and every day you have more and more of these tools that are pulling carbon from the atmosphere, and we start to see, instead of carbon rising every year, we start to see carbon either plateauing or even start to fall. That's the world where carbon removal is successful.
So we want to get it down from 415 parts per million down back to 300, and then after that, then we are back to what is the most effective sidewalks and frisbees. And you said graphene was one of the uses. So it's not that it may be the most effective building block for our environments, but for now we want it to be a building block for the sequestration and get back to that like homeostatic capacity of the planet where it was at, the 300.
That's right.
Yeah. So and this is okay. So on buynegative.com, that's where people can go and sign up again for the Carbon Products newsletter, and then you can find out more information about the little guy that you see here on the table, and the prototype, which will soon be something that people can actually buy and wear as well, that represents their efforts in getting a tangible product that resembles their desire to sequester carbon and share that with other people. Cool. All right, and then couple.
Are you going to leave that little plant with us, Tito?
That's the one that I carry everywhere. But you're on the mailing list, so
Oh, great.
So
you'll find out.
Our studio definitely wants an Impossible Labs a vase for a plant, because that way we can also be the bragging. We'll keep it right on the center of the main table, and we'll mention it and be like, hey, buynegative.com, like go and check this stuff out.
Great, let's make it happen.
Yeah, stuff like that. Yeah.
Sure. We're looking for sponsors.
Yeah, that's right. That's right. Yes, yeah, that's right. Everyone that's watching, listening.
If you want to carry this season, we'd be more than happy to sell those.
Whatever. You guys know. You guys all know. Yeah, including Tito and all the prospective people. To grow and support the artists and entrepreneurs in your community is so important. Support Simulation. All our links are in the bio. Carry. Ron's like, carry the support. That's right. We need the help. That's true. So, all right, let's hit a couple other thoughts. Okay, so you were teaching me this. I thought this was quite interesting. So once you do the process of sequestering something like carbon, turning it into a product, the moment that you start shipping it around the world, it actually takes away from what you were trying to do, which was make something that was net negative carbon emission. But the process of shipping.
That's right. Yeah, if you manufacture a product and you put it on the back of a internal combustion engine truck, that immediately starts to put carbon dioxide back in the atmosphere. And I think that's the beauty of making these products today. Is it's fun to be a part of the process of figuring this stuff out. Because right now it sort of comes together and you're like, hey, that's not exactly right. And so it's really exciting to be able to be a part of that process and then to start to think of new ways. Well, how do we actually make a carbon negative product? How do we make something that overall pulls carbon from the air? 1 trillion tons of carbon dioxide isn't going to fit on everybody's wrists. That'd be probably calculate how many tons of that. And a ton is the weight of a car. So it's car weights of this stuff. So burying the carbon dioxide becomes another option. So figuring out how to create carbon neutralization by taking carbon from the air and storing it underground, starting with these facilities in Iceland.
What would an ideal process look like for making a product that was net carbon negative?
I think an ideal process, you'd probably hear about this in kind of the 3D printing world, where it's like on-site, on demand. You're minimizing the transportation costs. You're basically energizing. You're avoiding any excess energy usage.
Yes.
So you're cutting out all these middle steps.
Yes, and then for me to get it would need to be locally manufactured, and then me to get it I would need to be local and take walk or bike or take some sort of maybe even an electric transit still has a battery that after 10 years has to that doesn't work as well, and it needs to be recycled. So this is tough to figure out what is net negative.
That's right.
And what would be a design of a city that would be net negative? Would it be your massive green everything and composting and air recycle water recycling, all these styles of processes were no emissions of internal combustion engines? These are kind of the things that you would see in a future city.
Totally. So what negative refers to is pulling carbon from the atmosphere. So if you're thinking about technologies that are carbon neutral, so if you switch from a internal combustion engine car to a electric vehicle, then your carbon emissions drop, but you're still not pulling carbon from the atmosphere. For example, if you wanted to, so instead, if you made your buildings, if you had a machine that would pull carbon from the air and created carbon-based buildings out of that, then you can imagine then that building itself would be net negative, would be actually pulling carbon from the air.
You'd be pulling carbon from there to make the blocks for a building, or pulling the carbon from there to potentially use as fuel for heating the building, that type of stuff.
Yeah, I like Elon Musk's brick store. So they're part of the boring company. They're digging these giant tunnels underground, or these long tunnels underground, and so they're selling the bricks of the underground material. So you imagine having like a brick store for carbon. It's really fun to get into because it's so few people have worked on this and thought about this. So if you're curious about this topic, it's something that you can go on Air Miners, you can learn about, and you can just start to contribute to. It's this very early industry that's emerging. So you can make up funny ideas like, well, what if there was a radio show that was everything on set was made of carbon dioxide pulled from the air? Like, it's kind of a joke, but then it actually sounds like, well, that sounds pretty cool.
Yeah.
Like maybe we should have a radio show like that.
Yeah. So then this is like like you said, this is kind of like the earlier, more formative years of air mining in general. And so the idea space for what can actually happen in the field is so untapped into.
Yeah.
What are the other like creative thoughts that you have around like where we could go with untapped creativity in the air mining space?
Sure. I certainly always go to like interplanetary travel and other planets. So mining carbon from the air is something that's certainly part of the future of Mars. Mars is, I think it's 95% carbon dioxide in their atmosphere or something. Whatever it is, it means that if we have technologies to pull carbon from the atmosphere, those would be really well used on Mars. Similar to if you have technology to grab power from the sun, Hawaii is a great place to go, and the North Pole is not a very good place. Mars is like a great place for carbon capture, and Earth every day is getting better. It's like heading in the wrong direction.
It's 95.3.
95.3.
Yeah.
Thanks for looking that up. Yep. So then, the process of learning how to air mine is exactly what we need for interplanetary processes. Yeah.
It's a way to look at an atmosphere, to look at a planet, and just to see it as something that we can connect with, we can work with.
Yeah. So what exactly? So then, what is the ecosystem of the planet? How can we work within the ecosystem of that planet? So, like on Mars, we take the skills that we learn with air mining and CO2 here, and we bring those skills to Mars to help us bring a civilization there.
Right.
Yeah. Okay, and then that was more on like the really future facing stuff. What about the examples that you're giving us about the companies that are where could people find their involvement? Like how can people get started with doing things like air mining, like even today, like here on Earth? How can people get started with this?
Yeah, going to air miners, learning about, seeing what the startup companies are doing. They're all really great to talk to. So when we were first setting up air miners, we were emailing all the companies and kind of crossing our fingers, like, would anybody write back? Lots of people wrote back. People are really engaged and interested in this field. So it's a great place to work. It's a great place to just to read about, and then to start to transform that into what might you do? What role might you play? Maybe it's building one of these machines or being a part of testing it. Maybe it's using the products or designing your own products even. There's all these opportunities for a whole range of different people. I like to say that right now there's a small number of people that are actually engaged and working on the changing climate. There's a lot of people thinking about it and kind of like waking up in the middle of the night frustrated about it. But in terms of like figuring out how to make it your day job or maybe your night job, I think there's a lot of opportunity there for millions of people to start being a part of it.
Okay, cool. So going air miners, reading and learning more, and then would you say there's a like would you say there's like a process for ones that want to creatively endeavor in this space? Is there like a think tank or a accelerator or are there ones like this that are specifically focused on the field?
We have a question in regards to that.
Oh, cool!
Kamal
Wow.
Labadi
Audience question.
asks if he was an investor, what would be the pitch to him? Is that what we're talking about?
If he was an investor, who? If
Cloud investor?
Tito was an investor?
No, if Kamal wanted to invest in...
In Impossible Labs?
Sure.
Okay, what would be the pitch?
The pitch is that there's 1 trillion tons of excess carbon in the atmosphere. Everybody thinks it's a problem, and it's actually an opportunity. And we're going to figure out how to prove that.
Oh, that's great, yeah. Nice and short, I like that.
Yeah. Mark O'Brien says hi, too.
Oh, cool, yeah. Hey,
Hey, Mark.
Nice. And then, how about the like accelerators, or think tanks? Like where can people potentially are there any in the space?
Yeah, obviously with Impossible Labs, we're doing some of that kind of think tank consulting work.
Yep.
I'd check out Carbon 180, which is a nonprofit just across the bridge.
Cool.
They are working on Carbon Tech Labs, which is an accelerator program designed for companies working in carbon removal. I'd also check out Nori, N-O-R-I. They are a blockchain carbon removal company that has a really great podcast. And so those are places to connect to get that acceleration. I've seen that lots of kind of new people come in and they say, gosh, since I heard about this, I can't stop thinking about it. Like it's so kind of counterintuitive, pulling carbon or even just kind of seeing it as this thing that we might want to grab onto. And I've just seen people really accelerate very quickly. So, in 6 months, you can become an expert air miner in a sense.
Mm-hmm. And then is it following that trajectory we were mentioning earlier in the episode? Is it kind of like we learn about all of the air mining technologies, capture these 1 trillion tons of CO2, bring ourselves back to 300 parts per million, really refine these different ways that we do that, take those technologies to places like Mars, these types of things, put them in the civilization's knowledge pool, and then we just build things that don't pollute CO2. That's kind of like the future then afterward?
That's right. So eventually you've pulled enough carbon from the air. One question that I get that I know is really funny is people ask, well, what if you cause an ice age? And so I think that really acknowledges okay, so that's somebody who's really thinking about, hey, this stuff is going to work, and then because if we went to
if you go too
200,
far,
100, return to a very, very cold planet.
Yeah.
So I think those are fundamentally powerful advances. For one, because this is molecular manipulation. It's what you see in synthetic biology a lot. Right now, in carbon removal, it's done it's using kind of chemistry and very raw, like physics. But I think as synthetic biology comes along, you're gonna be able to see, because that's what they're doing, is they're manipulating molecules. And so we're gonna get better at manipulating molecules. We're not very good at it right now. We're okay. We can do computer chips, which are like a few nanometers, but to really work on molecules, that's the age that we're in. And carbon fits in that, proteins fit in that, biology fits in that.
Okay, beautiful, beautiful. Now, maybe another wrapping thought with the field is the overall trajectory of our civilization. What is another way that we can remove our own carbon footprint that we're emitting on a daily basis? What are the simple ways that we can do that ourselves?
Yeah, I'm really interested in lab-grown meat. I think is really promising there. Electric vehicles are cool. We looked into buying one for our last car. Things like that. I mean, it's probably things that you've heard of. So to kind of step into things that you might not have heard of,
yeah.
I think that pulling carbon from the atmosphere is still this really exciting topic. But overall, so really to push it, I would say look for opportunities to work on this stuff. Look for opportunities to maybe you read 100 books this year, but just step into it. If the climate is something that you see as somebody else is telling you what to do, it just doesn't. It's not exciting and curiosity driven. So the more you can jump into it, if you really like food, great. Scramble around your diet and become vegetarian or vegan. If you like to drive, look into electric cars. They're pretty freaking awesome. Find a way to find something that you're excited about, or take the thing that you're already excited about, the thing that you talk about all the time, and people are like, wow, this person really likes this. And just Google that topic, plus climate or plus carbon and figure out like how might we think differently about this, because that's what we really need. Is we need jewelers to type in like, oh well, I'm a jewelry person plus carbon is like, oh well, okay, what if you made diamond jewelry?
Carbon sequestered
diamond jewelry, right? You can kind of just like take what you're doing and tag on carbon, and you'll come up with something that potentially and likely no one has ever even considered. Like,
love it.
Live broadcast plus carbon. Like, okay,
yeah, stuff like that.
What do we come up with?
Yeah, cool. So another one of the things is to take different edges of what is known by us and on our knowledge graph and try and plug these different edges into carbon sequestration plus neuroscience or plus blockchain or plus energy. There's so many options. Healthcare. Where could these things be applied? Yeah. Okay, cool. And then let's ask a couple questions on the way out. Do you feel like we covered Impossible Labs well? Do we
totally.
hit most of the stuff we needed to hit?
Yeah. The newsletter, I think, would love to see people in the newsletter. Mark, who wrote in, is one, and Mark and Sarah, the Determined, are part of the newsletter team. So it's like every week we talk about exciting stuff happening in carbon removal, and it's very personal. So it's not just like a reel of what happened. It's just more of a story about this adventure.
So that's a great way also for people to get engaged and involved. Again, that's the newsletter is at bit.ly/Tito-carbon. So go and find that there. The link's in the bio, everyone. Okay.
Should we take some more questions? Kamal has some more questions.
Okay, yeah, ask one of the questions and then we'll dive into the end show.
Well, he wants to know if can carbon capture recreate the reef or save it?
Recreate the reef or save it?
Good question.
Can carbon capture recreate the reef or save it? Reefs, I heard there's interesting stuff going on with taking corals and putting them in a blender and then kind of spreading it out or something. So I think there's some potential there. But yeah, to do like the reefs plus carbon sequestration thing, reefs might turn out to be a really great way to pull carbon dioxide from the air, combine it with calcium in the ocean, and to grow reefs. So maybe that becomes a place where we're comfortable and excited about pulling carbon from the air. Maybe our buildings and our sidewalks and our reefs.
And it seems as though when we head down from 415 parts per million down to back to 300, that slowly there's a process of healing that happens within the ocean acidification that's occurring.
Right.
So, yeah.
Of course, that's not something that anybody has ever thought of as reefs plus carbon sequestration. I've never heard that before. So
exactly.
Great. It's like you can come up with it, and what's your guess about it? Will it help or hurt reefs?
He's also looking to invest $5 billion. So come on, just send us a check. Go to PayPal at simulationseries@gmail.com, and we'll hook you up.
Yeah.
Great.
Also, what's Kamal's last name again?
Lamadi.
Kamal Lamadi?
Yeah.
He owes me $5.
No, he doesn't. Oh, for that sandwich.
For that sandwich.
Thanks for watching, Kamal.
Thanks for watching, Kamal. Mark, thanks for watching, everyone. We greatly appreciate it. Let's do a couple questions on the way out. Tito.
Great.
What do you think? Where do you think we come from before we're born into the world, and what do you think we go after we die?
That's a big Zen one. There's that whole Zen koan. It's like, what's your face before your parents were born, or something. I mean, we come from stardust. We come from Stephen Hawking's calculation of what's right before the Big Bang. I think we come from that sort of energy bouncing around, and intelligent life is right now just on this one spot, but it's obviously there's a lot of spots to explore and to discover.
What's the most controversial belief you hold?
It still seems like the idea that climate is an opportunity is something that, for the people that are really into the environment and climate, it doesn't quite sit very well to say. I think a lot of people are going to come along and make a lot of money working on this.
Yeah.
So that's
quite controversial. I agree. Yeah. Not many people are thinking about it that way.
Yeah. If you just put yourself in those shoes, the world looks so different.
Yeah,
just
as an opportunity.
As an opportunity.
Yeah.
I mean, it's just everything
rather
becomes
than something that is like, oh my God, we're all dying. Even though that's like
exactly. Throw a little financial incentive to
save the planet.
That's right. It's just that's what works for me. Is I get out of bed in the morning and I think about things that are exciting and fun and interesting. If it's a gloomy day outside, I'll just pull the covers up. You know, I mean, to me, I think the proof is kind of in seeing where the action is coming from. I don't see a lot of action coming from fear. It sort of gets stuck, and it becomes about people or interpretations or relativity rather than exploration and curiosity and solutions.
I love it. And this is exploration, curiosity, solutions.
This is that distilled down into a physical thing that you can say, okay, that's right. This is where it's at. This is the future is optimistic and driven by real things that are being actually developed. Like these things aren't just somewhere in the future and maybe somebody will invent it. There's a machine up in Squamish, British Columbia that's working to pull carbon dioxide from the atmosphere. And there's machines all over the world and tools all over the world and drones all over the world that are learning to plant trees at 1/100th of the cost of having a person go and plant it.
Yeah.
I mean, I'm grounded in possibilism is this term I came across recently. It's from Hans Rosling, who's a statistician. And he really believes in possibilism, which comes from, it's more than optimism. Optimism is like everything's going to be great, but possibilism is grounded in, here's the things that are happening. You're watching this show and you're seeing some guy who walks around with a planter that's made of carbon from the air.
Yeah.
Like, okay, that says a lot about what's possible in the future.
Yes.
And so embrace that possibilism.
Yes. So you carrying around the edge of what we're doing to solve some of the pressing challenges is you're constantly reminding people everywhere you go of that edge and increasing people's awareness. Yeah, that's great. How about, do you think we're alone in the cosmos?
Math tells me that we're not, but my eyeballs tell me that we are. Because I look out on the stars and I say, okay, doesn't seem like I see any life. But math tells me that there's a lot of stars and it seems like there should be life somewhere on one of them. Maybe not on the star, but on the planet around the star.
Yeah. Do you think we're in a simulation?
I think it's more exciting and interesting to live in the real deal first. And again, that's that same feeling as like as a human being emotionally, I want to be one of the first to explore this game, explore this universe. But then mathematically, it could be very likely that we're in a simulation. But I definitely think more that we're not, and this is exciting.
Good for you, Tito. Could be very likely that
the nuance approach.
Yeah.
And then what do you think is the most beautiful thing in the world?
I like retinas. I mean, they're very colorful and textured, and they're beautiful. And if you spend time looking at them, I think you'll be a happier, healthier person.
Wow.
It's the first time we've had that answer on the show. Yeah. I like that one. It is. It's actually like proven to be 30 to 60 seconds of just looking at each other in the eyes is like just proven to be so much more grounding for humans and emotionally embodying you. Like the whole thing where you're behind a computer keyboard like trolling or yelling at other people is like that gets canceled out when you look at them in the eyes for 30 seconds. You're like, wow, this is another human that is like has their own complex life, you know?
Right.
Yeah, versus behind this stuff is just, So, that's a good one. I like that one. You feel that oxytocin. Yum, 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 yum. Love. Yeah. That's good stuff. Tito, this has been an excellent episode. I really appreciate it. Do we have another audience question?
No.
Okay.
But Eugene Otto digs Tito's climate optimism.
I love it.
And,
Thanks, Eugene.
Kamal is working on a smart mobile game to capture 1% of what? To fund clean tech and organization that can save the planet and advance humanity. That's what we're working
Great.
on. So everybody
James.
that's watching the show, thank you so much for watching and participating.
We greatly appreciate it.
And be sure to send your contribution to simulationseries
Yeah.
at gmail.com.
On PayPal. Yeah,
we
do
can
do
use
hook it up. Yeah, literally a cup of coffee that you spend every single month can literally dramatically change the direction of our program and make it much more effective for us to implement what you guys would like to see as a more optimal show. So let's do it together. Tito, thank you so much for coming on.
Yeah,
and
it was
teaching
great.
us. Yeah, we
Thank
really
you.
appreciate it. Yeah, seeing things as an opportunity. I love it. The 1 trillion tons of carbon, let's sequester that. Let's see it as an opportunity, everyone. Check out the links in the bio below to the newsletter, as well as to buynegative.com, impossiblelabs.io, and airminers.org. Talk about these things with your friends, your family, coworkers, people online on social media. Get talking about this as an opportunity. Get talking about it, sharing it, get building in the space.
Where's the website to buy the mug?
Oh, for this, it's bynegative.com. Bynegative.com. Also sign up for the newsletter because the batch 2 is going to be coming of these soon because they sold out batch 1 already. And the newsletter links in the bio as well. And support the artists, the organizations, the entrepreneurs around the world that you believe in. Support them in your local community. Support Simulation. Our links are below. The $5 billion person. Yeah, just kidding. Yeah, get it. Even the $5 a month helps a lot, everyone. Seriously, yeah, really, really dive in there. Ron Vargas, thank you very much for producing and directing. We greatly appreciate it. And go build the future, everyone. Manifest your dreams into the world. Thank you so much for tuning in. We will see you soon. Peace.